Hi, in this video I'll show you how to set up the 104S gateway. So basically this will be the gateway. Okay, so you just simply add from function builder. You go here, press this, and just find the gateway over here. So once you've done that, in terms of the configuration, first let's go over here. So over here, as you see, this parameter over here is sort of like a whitelist. So if you enable this, then it will only allow the IPs that are configured. Otherwise, if it's no, it will allow any client to basically communicate with the server. And then the next parameter you should be concerned about in order to configure this will be a common address of the ASDU. So this ASDU address must match in order for successful communications. Right now it's 1. And then you have your cyclic data transmission. So if you have any cyclic monitor points, then you need this parameter will basically determine the period. So right now it's every 2 seconds. Okay, and then over here you have the you have the parameter for event. So basically if you have any value changing, then there will be an event command sent. So if you don't want any event, then you'll be basically putting no scanning. But if you want event, then you'll basically choose scan for events. And when you do scan for events, it also sends the timestamps. So you can choose the format over here. Okay, so the next thing you want to see is the database. So now you have the command qualifiers. This is a default command qualifier. So if let's say you have a control point which is not configured for any particular option over here, as you see one of these, then it will use the default qualifier. So for the short and the long pulse, you can change the duration over here, and this will be persistent output, so the output will remain. And obviously this only applies to the ASDU types that use these qualifiers. One of the important things will be to change the counts over here. So based on the number of points you're using, you will be changing the counts according to the ASDU types that you're using. So and for this example, I'll be showing you first the control points. So a single bit and also a single register. And later I'll show you the monitor points and monitor point for 16-bit register. And this is essentially to reduce the bandwidth usage. This one right now for basic usage you can ignore. Okay, so as I stated previously, if you're using IP list, then this will be the allowed list. So since I've selected no over here, this is actually ignored. Okay, so now the control points. So over here this is for the single bit. So over here you have your point. So this point must be unique, okay, and it must match on both the client and the server side. And this will be the actual location within the device that the data will be stored. So right now I'm saving the first bit in DB address 0, and this monitor point is basically a response to any control points that are 800. So if you want, you can have a response, but if you keep it to 0, then there won't be any response. Okay, so likewise for this, it's the same thing, except one thing you must note is the DB address will depend on the ASDU type. So right now this one is register type, so holding register type, 16-bit register type, sorry. So this one will be raised 2. So in the previous one, this one was actually bit 0, so if I were to make it 2, it will be bit 2, still within the first register. Okay, now let me show you a simulation of the client. So this is a free software, so QTester. So over here, this is most clients will have to obviously assign the IP of the server, and then this will be the originator address. So this is the client's address, and then you have to also assign the server's ASDU address. So this, since we configured to be 1 in our server, this will be 1. So let's connect. Okay, so now let's do an example. Let's say you want a single bit, so the value would be 1, and as I said stated previously, your point must match. So since I configured to be 800, so now let's make it 800, persistent output, let's send a command. Right now I'm transferring over to this PLC, and you see the data changed to 1. If I were to make it short pulse, let's say, then you will notice that it will change for a short duration. Say where you can see, yeah. So the send command, see, it goes back to 0 after a while. Okay, so now let me show you an example with C and set normalized value. Okay, so now the point I configured was 1100. So let's say put 22, and I send the command. You'll see the values changed. Okay, now next I'll talk about the monitor points. So unfortunately with the simulator I cannot show you monitor points, so I'll be using another gateway to show you the monitor points. So here I actually have another gateway configured as client. So the main things you would need to configure over here would be, again, the IP address, and then also the common ASDO address. Also the points must be assigned in the client side too, even for monitoring points. So always, even control and monitor both sides have to have the points configured with the points matching, point index matching. And this one is basically internal addressing where this data for these points will be transferred to. Okay, now let me just connect the device. So now before I show you the actual data changing, I just want to explain this bit. So for the monitor points, these are basically the single bit. So again, you just have to assign the point, the actual address within the device where you want to store it, and groups. So for groups, now let me show you what they mean. Okay, so if it's one of these values, then it will basically be event based. The data will be transferred based on events, or it can be interrogated by the client. If you use 8 in front of as a modifier, then it will periodically send the point data. So right now these are event based, and then for this one over here, this is your 16-bit register, so endpoint unique. Okay, and now this one is also event based. Okay, yeah. Okay, so now let's see the actual values changing. Okay, one thing I forgot to mention is right now I also configured from the client to request for point index 400. So even though it's event based, it will constantly send the data after every 3 seconds, because I'm requesting explicitly from the client itself. So now over here, this one over here, you see if I change it to 9, you see over here, oh, sorry, the wrong address, change to 99, you see it's reflecting over here. So now for the bit over here, if I change 0, you see the bit is 0, so actually it's these 2 bits. Change this one, you see this reflecting over here. So if you want to see actually the Wireshark capture, you will notice, okay, so normally there is only the explicit messages. Okay, and now if I do any event, there will be a spontaneous request. Okay, and that's all for the basics. Thank you.